Hi everyone, welcome back to rkphysicsshiksha.
In this video, let us discuss about a very important and an interesting concept, which is maximum and minimum values of a function. So this concept we will be using in some numericals that we will solve in physics as well. So to understand this, we'll just step into the depths of this concept a little, whatever is necessarily needed for us in physics. So coming to that, if you see the graph, I have plotted a graph between the component terms y and x here. So that means one is changing with respect to the other. So we clearly know in such a graph that you are seeing here on the screen now, the slope varies. The slope changes from the positive value to a 0, then it changes to negative value. So in some questions, we will be asked to find out the maximum value of that quantity or the minimum value of such a quantity, of a physical quantity. Most likely you can come across such model of questions in motion in a straight line as well. So to solve such model of questions, there is a very important and necessity that we understand this first. So for example, the slope of the graph at the maxima or the minima, we say it to be equal to 0. For example, what are the maxima and the minima points here in this graph here? This point here, which is I term it as A, is the maxima, and the point B is the minima of the graph. Point B is the minima of the graph. So if I draw a tangent at this point, a straight line like this, a tangent here and a tangent here, the slope at these 2 points is obviously 0. That means dy by dx at A is equal to 0 and dy by dx at B is also equal to 0. So if you are provided with the graph, okay, fine, at A it is maximum, at B it is minimum, you can see it and say it. But the thing is, if you are provided with a function that is varying, so what you have to do is, at both the points, at a minima also you have slope 0, at a maxima also you have the slope 0. So how do we specify the point A is the minima, sorry, the point A is the maxima and the point B is the minima? There is one rule here that we can do. First, before getting into that, let us understand one more simple rule. If you take a graph like this, or if we consider a graph like this, where we have a graph in which this is the graph we have, this is y-axis, this is the x-axis. Now if you look at this, if I draw the tangent here at this point, the slope is theta 1, and if I draw tangent here at this point, the slope is theta, or the angle is theta 2. At this point the angle is 0, and as if you see, or else it is better that I take a better diagram here. So for that, let me just take the x-axis and the y-axis. Right. Now if I plot a graph, as you see here in the diagram now, if you observe at this graph, the slope, we know already what the slope of the graph is. If you draw the tangent at a particular point, that tangent will give you the slope of the graph at that point. Now if I draw the tangent here, you have a theta 1, and if I draw the tangent here, you will have theta 2 at this point made at the horizontal. If I take the theta here, it is a horizontal line here, so this is here theta is equal to 0 degrees, 0. Or if I again go here, the theta again changes with the horizontal, it will make a certain angle again as we move down here, so that will be some angle here which you can take it as theta 1, theta 2, something like theta 4, oh sorry, theta 3, and if further I move, I consider it to be like this, which is theta 4. Oh, I think it looks a little mixed up, so fine. But if you look at this, the slope of the graph is gradually becoming from positive, because slope of the graph at any point you can take it as m is equal to tan theta. If theta is acute, slope is positive. Theta is obtuse, slope is negative. So now the slope of the graph changes from a positive to 0. It will change from positive to 0. It will go from positive slope to 0 slope, and from 0 slope to negative slope. Sorry, 0 slope to negative slope it will approach. So that means this point here, if I take this as the point A here, what is actually happening? I know by taking a higher order derivative, or by considering in general terminology by differentiating, or one variable changing with the other variable, if I consider at this point, firstly dy by dx at point A, which is the point of maxima, I'll get it as 0, because the slope is 0. The slope is nothing other than change in y by change in x. At that point A, you don't have any change in y with respect to change in x. So dy by dx is equal to 0 at the point A. So at the point B also it is equal to 0, but I don't know whether A is the maxima or B is the maxima. So for that, you have to understand that for at maxima, dy by dx is changing, meaning it decreases. Dy by dx decreases as at a maxima, meaning it becomes positive to 0 and 0 to negative. That means what we can say, dy by dx is equal to 0, and the rate at which this dy by dx changes, the rate of change of this dy by dx is negative at maximum. It is negative at maximum, meaning at maximum it will become 0, and further moving further it becomes negative. So that means the rate of change of means, again, the d by dx of the slope, that is the dy by dx, is going to be negative, that is less than 0, which is at maximum. Which is at maximum. That gives you double derivative, that is d square y by dx square should be less than 0 for the point to be a maxima. So that is the condition for maxima. Now what are the conditions for maxima? Condition for maxima. So dy by dx should be equal to 0. This is the first condition. If dy by dx is equal to 0, it can either be maxima or it can also be minima, because at a maxima and also at a minima you have the slope 0. But how do I verify whether that point is maxima or a minima? By taking the double derivative of it. D square y by dx square is equal to 0, or sorry, not equal to 0, it should be less than 0 for it to be a maxima point. Similarly, if you take a graph for the lower curve, that is, as you know, here I'll draw it for our reference. Now if we consider a graph like this, in which we are going to take a minima point, that is the point B. So as you look at this graph now, the slope at any point, at this point you consider, 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 and this point you consider. Drawing the tangents, and if you take the horizontal at that point, this will be theta, and drawing a tangent here, that will give me the slope at this point, that will be theta again, theta 2. At this point, if I draw the tangent, it will be theta is equal to 0. At this point, if I take the theta value, the horizontal, it will be theta 3. And if I draw the tangent here, again it will be theta 4, like this. That means the slope of the graph, that is dy by dx, is actually changing from negative to 0 and 0 to positive, meaning the slope is increasing here. In the previous case it was decreasing, dy by dx decreases at maximum, but in case of minima, dy by dx increases. So by this, what we can say is very clearly, the rate of change of slope is increasing. That means it is becoming greater than 0, means it is becoming positive after the point of minima. That means the rate of change of y with respect to x is becoming greater than 0, means it is becoming negative to positive. At minima it is 0, and from that the slope is gradually increasing. So that means it becomes greater than 0. Means the slope is, the rate at which the slope is changing is becoming positive. So what we say the condition now for minima is, the condition for minima, obviously first condition is that dy by dx should be 0, and to specify whether it is minima or maxima, we have to double differentiate it, double derivative we have to consider. That gives me, for minima condition, that gives me like d square y by dx square should be greater than 0 for the point to be a minima point. Let us look at an example also. Let us take an example and solve it also. So let me take a function, a random function, let us consider, and we'll find out the maxima and the minima values for that as well. So in this question, I consider y as a one which is depending on x as x cubed minus 3x square plus 6. Now here we have to find maxima and we have to find minima of this function where y is depending on x, right? What is the condition that we have for the point to be maxima or minima? What should actually happen? Dy by dx should be equal to 0. So first let me calculate the dy by dx. That is dy by dx is equal to d by dx of x cubed minus 3x square plus 6. Differentiating it, d by dx of x cubed minus 3 is a constant, so d by dx of x square multiplied plus d by dx of 6, which gives me, this relation that we can use here is d by dx of x power n is equal to n into x to the power of n minus 1. So in the place of n here in the first relation we have 3, so it will become 2x square minus 6x, and differentiation of a constant is 0. Differentiation of a constant is 0. This is the dy by dx value of the given function. So for maxima or minima, for the point of to be maxima or minima, dy by dx should be equal to 0. Dy by dx value should be equal to 0. So in that case 2x square minus 6x equal to 0, from which x, if I take common, I'll get it as 3. Oh, sorry, my mistake. This is 3x square. 3x, 3 into x to the power of n minus 1. So this will be 3 here. So 3x minus 6 is equal to 0. So for which the values of x will be x is equal to 0 is 1 and x is equal to and 3x minus 6 is equal to 0. That gives me x is equal to plus 2. So these are the 2 points at x is equal to 0 and x is equal to 2. We'll either have minima or maxima. But we don't know. By just seeing 0 and plus 2, we cannot say that x is equal to 0 is the point where it is minima and at x is equal to 2 is the point where it is maxima. We cannot say that. So for specifying the point x is equal to 0 to be minima or maxima, we have to double differentiate the given relation here. So we have already dy by dx. So what we'll do, d by dx of dy by dx is equal to how much? We'll just differentiate it. So d by dx of, what is the relation that we have here now? Double differentiation, 3x square minus 6x. So 3x square minus 6x is the relation. So in this case, d by dx of 3x square minus, so this is 6x minus 6x minus d by dx of 6x. So if you differentiate this, I'll get it as 6x minus 6. This is d square y by dx square. This is the relation for double differentiation. Now this value of d square y by dx square at maxima, it should be less than 0, and at minima it should be greater than 0. So I have two values. For x is equal to 0 is one case, and for x is equal to plus 2 is the other case. So d square y by d square dx square at x is equal to 0, let us see how much you will get it. Substituting x is equal to 0, I get it as 6x means 6 into 0 minus 6. That gives me minus 6. See here, which is less than 0. So next one is d square y by dx square at x is equal to 2 will be equal to 6 into 2 minus 6. So that gives me 6, which is positive, which is greater than 0. So at x is equal to 0, d square y by dx square is less than 0, and at x is equal to 2, d square y by dx square is greater than 0. What did I give you as a condition for maxima or minima? If d square y by dx square is less than 0, that means that is the point of maxima. So you will have maxima at x is equal to 0. You have maxima at x is equal to 0. The value of y will be maximum at x is equal to 0. And its value will be minimum at x is equal to 2. We'll have a minimum value at x is equal to 2. Let us calculate that values also. Maxima of y, that is at x is equal to 0. So that means in the equation provided, which is x cubed plus, it's minus 3x square plus 6. So if you substitute x is equal to 0, 0 minus 3 into 0 plus 6, that means the maximum value of y is 6, and the minima of y is at x is equal to 2. So what will be that minimum value equal to? x cubed minus 3x square plus 6 is the relation. So y is equal to x cubed is 2 times 2 times 2, that will be 2 cubed minus 3 into 2 square plus 6, that will be 8 minus 12 plus 6, that gives me 2. So the minimum value of y is 2, which is at x is equal to 2, and the minimum value of y is 6, sorry, the maximum value of y is 6 at x is equal to 0. These models, I have just taken the variables as y and x, but in the numericals that we come across in related to velocity and energy relations, we will be using the same condition as well. So it will be helpful. Please leave a comment if any other such concepts are there in your mind which you wanted me to teach. It will be a great gesture from your end, such that we will also be able to feel that we are delivering what is necessarily needed.